All right, can you see my,
Yes, yes.
cool,
Yeah, we see it.
awesome. All right, so this is the schedule for the day. We're starting right now with the syllabus. In about 10 minutes or so, I'll get started with the introduction. A few minutes later, we'll go into loading modules and running the Matlab codes, running really basic Matlab code. We'll have a brief break about 10:50. 11:05, Brigitte will take over and talk about using MATLAB with the Slurm job scheduler in a uh, in a non-interactive sense. And then after lunch, we'll have a simultaneous session where um, if you are on a computer that uses the interactive or slloc command to start sessions on the to start interactive sessions on compute nodes, then you'll go with Bjorn. And if you use MATLAB on a facility with desktop on demand or open on demand, you'll come with me. And I will show demonstrations on the LUNARC and HPC2N systems. And the LUNARC system demonstration will more or less be the same as what you would see in Dardel if you're lucky enough to get a ThinLink session on there. After that, Pedro and I will go into using the MATLAB GUI with Slurm. So that's there's a batch command that you can use within MATLAB to submit jobs from there. And we'll talk about configuring that and running that. Then Bjorn will come back and discuss add-ons. And, so these are the toolboxes that don't come pre-installed, but that you can go out and download later. Then we'll have one last little coffee break just before 3, then the summary, evaluation, and some Q&A. And I'll go into, I think I cover most of. So by the end of the day, we hope that you will be able to load MATLAB modules and locally installed MATLAB packages. You'll be able to create a MATLAB environment, install MATLAB packages with the add-ons manager, write a batch script to run MATLAB, run batch in MATLAB, use MATLAB in parallel mode, use GPUs with MATLAB, and later on in the week, we'll discuss, so GPUs and machine learning with MATLAB will be discussed, I think, on Friday. So GPUs, I think we moved that to Friday. We'll discuss the best practices at each of these facilities that are affiliated with NAISS. So we have UPPMAX, HPC2N, LUNARC, NSC, and PDC. And we have documentation for all of them, but which ones we go into detail in sort of depend on who is attending. So for some of these we may skim, but we will touch on all of them. As I said, Bjorn will cover toolboxes and add-ons and getting better HPC. And Pedro and I will go into more onto getting better HPC performance with MATLAB. We're not going to be talking about coding, improving your coding skills, and we're not going to be going into detail on other clusters that are not listed up here. However, there is some documentation at the end of this page that will help you with these things. So I already covered the schedule. So let's just go ahead and start into the introduction now. MATLAB is a numerical computing environment, and it's a high-level programming language. Some people might refer to it as 4th generation, but since the 3rd generation onward, the generation syntax has somewhat lost its meaning. It used to mean sort of both like an expression of the capability and the expression of the power and also the level of abstraction away from computer readable language towards human readable language. So Matlab is very, very heavily prioritized towards making it not just human readable, but so that it actually starts to be able to insert code for you. So Matlab was developed by MathWorks. It was originally developed for matrix multiplication, and that's still a central part of its engine. It also does it also helps with plotting and it can also do very advanced plotting and it can implement pretty advanced algorithms up to and including machine learning algorithms. It has widgets to help you to create user interfaces. It has some tools to interface with other programs in other languages like Python, and I believe there's also an interface with Julia, and an interface with R. And although it's numeric only, there's an optional toolbox that uses the MooPad symbolic engine, so you can do computer algebra, so like symbolic math, instead of having to actually input numbers. Some of the pros of MATLAB, it's probably the one that attracted me was that it's a low code interactive environment. So a lot of very common data import methods and analysis techniques, plotting formats, and even some machine learning algorithms. A lot of these can actually be run from menus, and they generate code in the background. And you can view that code, but you can also just work purely in, you can also work mostly in a GUI type environment where you're like entering numbers into boxes in a graphical interface. So that's really, really nice. Something I really wish I had in undergrad and grad school. It also has a rich library of toolboxes and add-ons for a very wide variety of different STEM disciplines: engineering, chemistry, astrophysics, geology, robotics, you name it. MATLAB is really, really strongly geared towards being able to do advanced simulations, and all of these tools are written. Most of these tools, and particularly the ones that you are able to install when you first, or that sort of come installed on your local facilities MATLAB distribution, those packages are all written and tested by pros. You can also set cluster configurations and parallelization settings graphically. And you can save into profiles that can be preserved between sessions or toggled between at a click. There's also, it also has automatic multi-threading, which is both good and bad. This is a double-edged sword. I'll talk about that momentarily. There's also full documentation straight from the command line, but that requires an internet connection, which most of the people who are using MATLAB will be using it with an internet connection. And in fact, they do have their own parallel clusters that you can connect to if you leave the university environment and go say towards a more industry environment. There are some cons, of course. It's a proprietary language, so you need a license and to sign up for an account to get the full benefits. Students and faculty at universities typically get these through the university, so you don't really have to worry about paying for it if you're affiliated with a university and doing this for research, not for commercial development. If you're into commercial development, then you have to pay. A lot of the add-ons also might require a separate license. With respect to the two-language problem, which is where one can optimize for either performance or ease of prototyping, which typically implies ease of actually writing the code in a way that's human readable. You can optimize for one or the other, but typically not both. And MATLAB, even more so than Python, is geared towards being user-friendly, so it can be slow. Also, the way that MATLAB automates multi-threading means that it will typically just grab as many resources as it thinks it needs. And so whatever is available, if it thinks it needs it all, it will take it all. So that means that it can and will hog a full node if you let it. And that can be really bad if you're on a front-end node or a login node. So you have to, especially if you're running from, if you're not sure where you're running, or you know that you're running on a command on a front-end node or a login node, you really need to start MATLAB with this single comp thread flag in order to prevent it from eating all of the resources that it can get its hands on. And lastly, this is more of an annoyance than a genuine problem, but the built-in plotting functions, when you look at them in the GUI, they're very low resolution raster graphics, and the anti-aliasing is really disappointing for as long as it's been around. But what the GUI shows is not necessarily how the saved image will appear. So you can make publication-ready plots in MATLAB, but you have to do a lot of tuning of the graphics parameters, and you'll have to repeatedly export the image to special file formats like encapsulated PostScript, EPS. And so then you have to check your work outside of MATLAB in order to make sure that you have something publication ready. It's, like I said, it's annoying, but it's not prohibitive. So if you want to learn more about, if you want a continuing reference to the MATLAB documentation at your respective NAISS HPC center, here are all the links to the different centers in their local documentation. Follow whichever one you need, or whichever ones you need, plural. Bookmark them, have them on standby. And then if you want the official MATLAB documentation, you can just go here to MathWorks. Or if, like I said, in the GUI, you can also look up whatever functions that you need to look up in the GUI, and it will take you to the MATLAB documentation from there. There's also this page for extra materials. Oops, this looks to be deprecated. I'll fix that shortly in one of the breaks. Anyway, so in summary, MATLAB is a high-level computing language with an interactive environment that can generate code to handle certain very common problems for you. So that's really nice. Parallelization is easy with the GUI, but you have to be careful if you're starting on a login node to set the single comp thread flag to make sure that you don't hog a full node unintentionally. So these, now that I'm looking at it, these two statements seem like they're clashing, but you'll see later that the settings that you have for the GUI itself, or for interacting with the MATLAB interface, do not necessarily affect jobs that are submitted to the batch system. So you can submit parallelized batch jobs and not have to worry about the settings for your for the interface hindering that batch job. All right, how are we doing on the schedule? Why, that was working before. All right, so we're a little bit ahead of schedule, but that that's a good thing because loading modules and running MATLAB codes will probably take more than was assigned, so I'm just going to go ahead and dive in.